Alright, so now we're going to try an example. Okay, so let's put this all into context. So I'm taking the example from page 293 of the textbook, so it's got the calculator stuff that you can go to and follow through if you're not sure. I'm also going to post my calculator working in just below this video as well, so you're going to have to do a bit of jumping around. But example 2, 8 people were asked for the favourite genre of music: pop music, classical, or jazz. The results are in the following table. Okay, so notice we have a total column, we have a total row, we have 80 people in total, 38 males, 42 females, and a chi-squared test was carried out at 1% significance level. The critical value is 11.35. Write down the null alternative, show that the expected value, write down the number of degrees of freedom, blah 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 blah. Okay, so we've done all of this. You might want to go back, watch the videos again, just take your time through this, okay? So let's write down the null and alternative. So null hypothesis H0. Our null hypothesis is that, let's find the thing, genre of music, favorite genre of music is independent. It's chi-squared test of independence, independent of gender, our second variable. Okay, so 8 people, gender, our gender is independent. Our alternative hypothesis H1, favorite genre of music is dependent on gender. Okay, so do males and females have different choices in music? Okay, well, that's what it's asking. So B, show that the expected value for the female liking pop is 21. Okay, so remember this table is our observed data. We need to use our totals for this. So let's reread it. It says female pop. So we've got total number of females, total number of pop. So that's going to be 40 times by 42 divided by 80. Reaching for your GDC. That gives you a value of 21. 21 is what's given in the question, and we are sorted. Okay, so finally, part C. Write down the number of degrees of freedom. Okay, so remember these numbers, did they arrive? Is there any constraints on them? Let's do it the straightforward way. Remember, the calculator will verify this for us, but if we have to show it, we're going to do it like this. How many rows do we have? 1, 2 rows. So we're going to 2 take 1. How many columns? 1, 2, 3, 4 columns. 4 take 1. That's 1 times by 3. It gives us a value of 3. This has 3 degrees of freedom, okay? Which is it's the same as the earlier example. Okay. Now, you'll have to sort of pause this, go to the link below and check out the video on finding the chi-squared test statistic and the p-value. I've already done that, and my chi-squared test statistic, chi-squared calc, is 1.622 to 3 significant figures, and my p-value is 0.654. Alright, and now comes the challenging bit. E. State whether the null hypothesis is accepted or not, giving a reason for your answer. If you do not give a reason, you do not get any credit for this. So let's just draw a chi-squared distribution. Okay, earlier in the question we were given a 1% significance level, so we know that this area is 0.01. It's small, it's tiny. The critical value for this is 11.345. Right, let's compare our values. So from earlier, we've got 1.622 is our calculated value. So our calculated value is in here somewhere. Our so let's just go with the red. So according to the red, we're not in the right. Okay, so our judgment is accept H0 or do not reject H0. Accept H0. Why? Because 1.622 is less than, less than, let's sort that out, our critical value. We're in our safe area, okay? Or if we look at the probability, okay, so if we go for the p-value of 0.645, that's a big area, 65%, okay, so we can accept H0. Why? Because 0.654 is greater than 0.01, which is our significance level earlier in the question, okay? So you've got to be able to make a judgment on your test statistic or your p-value. Remember, this is the example from the book, so go back to the book, have a read.